Today we're going to talk about chapter 8.4, which is scientific notation. Scientific notation is when a number is written in the form c times 10 to the n, where c is greater than or equal to 1 but less than 10, and n is an integer. Okay, so an integer means a positive or negative number or zero. It can't have any decimals, so it's just a number without any decimals or fractions. C is going to be written in decimal form. You're never going to have fractions in scientific notation, so if you have a decimal, you're only going to have, you have to have a ones value, and then you can have a decimal after that. You cannot have a tens value, place value in scientific notation, because we have to be less than 10, and you have to have a ones value, because you have to be greater than or equal to 1. Okay? So, we are going to, if we have 2 million, we're going to look through this, and we're going to find the number that we can choose to be between 1 and 10, or equal to 1. Okay, and we see a 2, so we're going to pick 2. If we pick 20, we're too big, and if we pick 0.2, it's not big enough. So if we pick 2, we are going to put this in 10 to the n form, which is counting by 10 increments. Okay, when you think about decimals, every time you multiply by 10, your decimal moves to the right, and every time you divide by 10, your decimal moves to the left one spot. Okay, so if I were selecting 2 as my C, that means that my decimal would be starting right here at this spot. So how many spots do I have to move and which direction in order to get 2 million? Okay, so if I'm starting right here, I travel 1, 2, 3, 4, 5, 6 spots in a positive direction, which is to the right. So I'm going to be taking 2 times 10 to the 6th power. Okay? Here we have 5 1,000ths. So we're going to search through this number to look for a number that satisfies this. We have to be bigger than 1 but less than 10, or equal to 1. So we're going to pick 5. If we pick 5, our decimal would be starting actually here. If we started it here, that would be 0.5, and that's not big enough to satisfy our rule. So if we start at 5, how many decimal spots am I moving in which direction in order to get 5,000? So here I'm moving 1, 2, 3 spots to the left, which is a negative direction. So I'm going to have 5 times 10 to the negative third. Okay? Alright, so let's do some examples. We're going to write these numbers in scientific notation. Okay, here we have a lot more numbers to deal with, as in different numbers. Okay? Looking at these digits, the ones that are not zeros, we want to find the number that is going to be between our 1 and 10. So I'm going to pick right here in between the 4 and the 2. So I'm going to select 4.259. Okay? You can't select anything else. If we picked 42.59, it would be too big. If we picked 425.9, that would be too big. So we have to make sure that our scientific notation has all the numbers encompassed in the original number, but in its definition. Okay? So, if I'm starting at 4.259, how many spots, how many place values do I have to move in which direction in order to get this number, 42,590,000? Okay, so if I start in between, the decimal in between the 4 and the 2, I have to move 1, 2, 3, 4, 5, 6, 7 spots to the right. Right is positive, so that means I'm going to be multiplying this times 10 to the 7th power. And this would be your answer. Okay? Down here, I'm looking at these significant digits, and I'm going to pick 5.74 as my C, because that is between our 1 and 10. And in order to get this number, I would have to move 1, 2, 3, 4, 5 spots to the left, which is our negative direction. So I'm going to be multiplying that times 10 to the negative 5th. And that is your answer. Okay? Working backwards. We are now looking at numbers in standard form. We're going to write in standard form, excuse me. Okay, so this is given in scientific notation. I have 2.0075 times 10 to the 6th. Positive 6 means I'm going to be taking this decimal and moving it in a positive direction 6 times. So I'm going to have 1, 2, 3, 4, 5, 6. So that means I have to add zeros in here whenever I run out of spots. So the number that this equals in standard form is going to be 2007500, which is 2,007,500. Okay? And down here I have 1.685 times 10 to the negative 4. Negative, we're moving in the left direction, 4 spots. So I'm going to go 1, 2, 3, 4. I put in zeros wherever I have blank. So the number in standard form that I actually have is 0. I have 0.001685. Okay? And that is how to write a number in scientific notation. Okay? Next, we are going to learn how to compute in scientific notation. It's actually very simple, and we're going to be using the properties that we learned all last week. Okay? So, if we're multiplying two numbers in scientific notation, we're actually going to be multiplying like things. So here we have 8.5 times 10 to the 2 and 1.7 times 10 to the 6. When we multiply them, we're going to multiply our c's together, which is going to be right here. And then we're also going to be multiplying our powers of 10 together. Okay, so we multiply like things. Alright? 8.5 times 1.7 is 14.45. 10 squared times 10 to the 6th. We're going to use our product property here. When we multiply things with the same base, we keep the base and add the exponents. 2 plus 6, which gives us 10 to the 8th. Okay? Now, we're not done here because we are breaking a rule. Right here, our c has to be equal to 1 or in between 1 and 10. And we are bigger than 10. So, 14.45 can be written as 1.445 times 10 to the first. Right? Because if we would have taken this decimal and bumped it 1 over, we would have gotten our original number. So once we have that rewritten in proper scientific notation, then we can multiply again these powers of 10, and 10 to the 1 plus 8, using that same property as above, is going to give us 10 to the 9th. So our final answer is 1.445 times 10 to the 9th. Okay? Here when we divide, it's the same thing. We divide our c's. Okay, so we're going to be dividing this part right here. And then we're going to be dividing our powers of 10. So right here, using properties again. Okay, so we're going to take 1.2 and divide it by 1.6. We have this little times here because that's our scientific notation. And then we have 10 to the 4th times 10 to the negative 3rd. Okay, 1.2 divided by 1.6 is 0.75. And 10 to the 4th times 10 to the 3rd, when we divide, what do we do with our exponents? We subtract. So we have 10 to the 4th minus a negative 3. Minus a negative means plus, so we have to the 7th power, just right there. Check. Okay? Again, we're breaking the rule because we are not equal to or greater than 1. We have 0.75. So 0.75 can be written as 7.5 times 10 to the negative 1. And then we have times our 10 to the 7th. Alright, then we're going to simplify by, again, combining our powers of 10 by adding the exponents. So we're going to have 10 to the 6th. So we bring down our 7.5 times 10 to the 6th. Okay? And last but not least, we have our powers. Okay? Again, we're going to be taking like things to the power. This is actually using our power of a product property. Okay? Which means that when we have something that's multiplied together, we take the power to both of those pieces. So we're going to have 1.5 squared times 10 to the negative 3rd squared. 1.5 squared is 2.25. Perfect, we're within our rules. Awesome. And then we have 10 to the negative third squared. That's our power to a power property. So when we have power to a power, we multiply those little guys. And negative 3 times 2 is a negative 6. Alright. Okay, so we are going to finish up by doing some examples. Okay, our first example is that we are going to order these three numbers from least to greatest. Okay, so if we want to order something from least to greatest, we want them to all be in the same form so that we can compare. Okay, so we have 2.7 times 10 to the 5th and 3.401 times 10 to the 4th, and then 27,500. Alright, which one of these is not like the other? This guy. Alright, so we're going to put this one in scientific notation, which is, we put our decimal spot right here, and you guys can't see that color. Throwing that away. Okay. Right here, we're going to have 2.75 times 10 to the 1, 2, 3, 4. Okay? So, if we're going from least to greatest, that means that the smaller exponent on our base of 10 are going to be the smaller numbers. So far we have a 4, a 4, and a 5. So just from looking at that, we already know that the one with the 5th power is our biggest one. So we'll put that there again. 2.7 times 10 to the 5th. Okay? Comma. Alright, so now we have these two, which are both 10 to the 4th. Okay, now we just compare the numbers out front. So is 2.75 bigger or is 3.401 bigger? You got it. 3.401 is bigger. So we're going to have 3.401 times 10 to the 4th. And this number, 27,500, is our baby. So that is least to greatest. Okay? Alright. Now let's practice our computation using powers. Here we have 1.3 times 10 to the negative 5th, all squared. Okay, we're going to use our product, power of a product property. So we're going to take 1.3 and square it, and then we have our 10 to the negative 5th squared. Okay? 1.3 squared is 1.69 times power to a power. That means that we take those exponents and multiply them together. Negative 5 times 2 is a negative 10. So our final answer is going to be 1.69 times 10 to the negative 10. Boom. Okay? Here we have division. We are going to divide our c's, and we are going to divide our powers of 10. So we're going to take 4.5 divided by 1.5 times 10 to the 5th divided by 10 squared. 4.5 divided by 1.5 is, for those of you who can do that in your head, that is 3. And then here when we divide powers with the same base, we keep the base and subtract the exponents. So our final answer is 3 times 10, 5 minus 2 is 3. Okay? And last but not least, we have this lovely problem, 3.4 times 10 to the 7th times 4.2 times 10 squared. Okay, so we're going to multiply our c's together and then multiply our powers of 10 together. So we are going to have 3.4 times 4.2 times 10 to the 7th, I should make this a dot so it's not confusing, times 10 squared. Okay, 3.4 times 4.2 is 14.28 times 10 to the 7th times 10 squared is going to be 10 to the 7 plus 2. Okay, we are breaking a rule. 14.28 in scientific notation, we have to have the decimal there. So 14.28 is 1.428 times 10 to the 1 power. And then we have this times 10, 7 plus 2 is 9. Okay? Then we are going to multiply our powers of 10, so this number stays 1.428. Now that it is legal and correct, it stays times 10 to the 1 plus 9 is 10th power. There you go. Notice, when you are given problems in scientific notation, answers are also in scientific notation. Alright? And that is 8.4.